Hi everyone, today we are going to learn about Gaussian Elimination method. Gaussian Elimination method is one of the algorithm in linear algebra for solving system linear equation. From the linear equation, first we will form the row echelon form and we will do substitution in the equation to find the value of the variable. There are two types of Gaussian Elimination method. One is 2 by 2, another one is 3 by 3. 2 by 2 Gaussian elimination method is easier than 3 by 3. In 2 by 2 Gaussian elimination method, first we will transform the linear equation into an augmented matrix. Then we will try to change the augmented matrix into a row echelon form. At last, we will substitute the value of y in equation to get the value of x.
So now I'm going to explain how to solve matrix 2 by 2 using Gaussian elimination method. So the question is 3x plus 5y is equals to 9, 2x plus 3y is equals to 5. We need to find the value of x and y using the Gaussian elimination method. In order to solve the problem, we need to convert the linear equation into augmented matrix format like this. So now we're going to transfer the coefficient of the variables into the matrix format. Now we transfer the first equation, 3, 5. Always remember that the value after the equal sign must be placed at the right side separately, like this, 9. Now second equation, 2, 3, and then 5. In Gaussian elimination method, we need to solve until the diagonal of the matrix become 1 and the value below the diagonal becomes 0. So the end product should be like this. The value inside the diagonal must be 1 and the value below the diagonal always must be 0. It can be any number above the diagonal, but the value below the diagonal always must be 0. So, to achieve the end product, we always must start with the first row of the first column. So here, we need to start with the 3. So, I'm going to multiply R1, which is row 1, with 1 over 3 to make the value of 3 into 1. So, 1 over 3 times 3 is equals to 1. So, we write down the new value below that. And always remember that in Gaussian elimination method, you must do exactly the same thing to everything in the same row. So now 1 over 3 times 5 is equals to 5 over 3, right down there. And then 1 over 3 times 9 is equals to 3. So right there. Now, after solve the first row, we need to solve the first column. So I'm gonna do row 2 minus 2 to make it 0. So 2 minus 2 is equals to 0, right down there. And then always remember, do the same for the whole row. So 3 minus 2 is equals to 1, right down there. And then 5 minus 2 is equals to 3, right there. So now we achieve our target, which is make the value in the diagonal into 1 and the value below the diagonal into 0. Now we're going to convert the matrix into the equation back. X plus 5 over 3y is equals to 3, y equals to 3. So here, x plus 5 over 3y equals to 3 will be the equation 1. And y equals to 3 is going to be equation 2. So now in order to get the value of x, because we already get value of y, which is 3, we're going to substitute equation 2 into equation 1. So x plus 5 over 3, we substitute the value y there, equals to 3. And then 5 over 3 times 3 is equals to 5. So it will be x plus 5 is equals to 3. And then we bring the 5 to the right side. So it will be x equals to 3 minus 5. So the value will be x equals to negative 2. Now we already get the value of x and y, which is x equals to negative 2 and y equals to 3. So the problem is solved.
Three by three Gaussian elimination method is a little bit complicated, but the steps are same as 2 by 2 Gaussian elimination method. At first, we'll transform the linear equation into an augmented matrix. Then we'll try to make a row echelon form from the augmented matrix. In the end, we'll substitute the value of variable y and z in the equation to get the value of x.
So here I'm going to explain how to solve matrix 3 by 3 using Gaussian elimination method. So the question is 3x minus 2y plus 8z is equals to 9 and negative 2x plus 2y plus z is equals to 3, and then x plus 2y minus 3z is equals to 8. So we have three equations here with three variables. What we're going to do is we're going to take the coefficient of the variables and place it into the augmented matrix format. So now we place the coefficient of the variable and the value after the equals into the matrix format. 3, negative 2, 8. Always remember that the value after the equal symbol must be placed separately at the right side of the matrix. So 9. And then negative 2, 2, 1, 3. 1, 2, negative 3, and then 8. So now the objective is to change the diagonal value into 1 and the value below the diagonal into 0. So the end product should be like this. So, all the diagonal values are 1 and it can be any value above the diagonal, but the value below the diagonal always must be 0. So alright, how to do that? Well, we can add any two rows together. We can multiply any row by number added to another row and so forth. So we're going to take number 3 here and turn it into 1. So always remember that to start with row 1 and column 1. So now how to make the value 3 into 1? If you notice, we can add row 2 to row 1 to make the value into 1. So 3 plus negative 2 is equals to 1. So write down the value below that. And don't forget that we must do exactly the same thing in everything in the same row in Gaussian elimination method. So negative 2 plus 2 is equals to 0. And then 8 plus 1 is equals to 9. 9 plus 3 equals to 12, right down there, leaving everything else as the same. Next, we need to solve row 2 in column 1 to make it 0. So I'm going to do 2 times row 1 and add with row 2, which will be like this. 2 times 1 plus negative 2 is equals to 0. Right down there. And same thing goes for the whole row. So 2 times 0 plus 2 is equals to 2. And then 2 times 9 plus 1 is equals to 19. Right down there. And then 2 times 12 plus 3 is equals to 27. Write everything else as the same. In order to complete the column 1, we need to solve row 3 here. So I'm going to multiply negative 1 with row 1 and add with row 3. So it will be like this. Negative 1 times 1 and then plus 1 is equals to 0. Right down there. Same thing goes for the whole row. So negative 1 times 0 and then plus 2 is equals to 2. Negative 1 times 9 and then plus with negative 3 is equals to negative 12. And then negative 1 times 12 and then plus with 8 is equals to negative 4. Right down there. And leave everything else as the same. Now, I'm gonna turn this value into 1. So I'm gonna divide it with 2. So 1 over 2 times 2 is equals to 1. So write down there. And then same thing goes for the whole row. So 1 over 2 times 0 is equals to 0. And then 1 over 2 times 19 is equals to 19 over 2. Write down there. And 1 over 2 times 27 is equals to 27 over 2. Write it down there. Leave everything else as the same. So now I need to change the third row of column 2 into 0. So I'm going to multiply negative 2 with row 2 and then add with row 3. So negative 2 times 1 and then plus 2 is equals to 0. Write down there. Same thing goes for the whole row. So negative 2 times 0 plus 0 is equals to 0. And then negative 2 times 19 over 2 and then plus with the negative 12 is equals to negative 31. And negative 2 times 27 over 2 plus with the negative 4 is negative 31. And write everything else as the same. To achieve the diagonal 1, I need to change the value of column 3 in row 3 into 1. So I'm going to divide row 3 with negative 31. So negative 31 divided by negative 31 is equals to 1. And then same goes for the whole row. So 0 divided by negative 31 is equals to 0. And then 0 divided by negative 31 is equals to 0 again. And then negative 31 divided by negative 31 is equals to 1. Write everything else as the same. So if you see here, we already achieved our target, which is make the diagonals into 1 and the values below the diagonal into 0. So we're going to convert the matrix into the equation back. So x plus 9z is equals to 12 and y plus 19 over 2z is equals to 27 over 2 and then z equals to 1. So here x plus 9z equals to 12 is going to be equation 1 and y plus 19 over 2z equals to 27 over 2 is going to be equation 2. If you see here, we already get our z value. So z equals to 1 is going to be equation 3. In order to get the x value, we're going to substitute equation 3 into equation 1, which will be like this. X plus 9 times the z value, which is 1, and equals to 12. So 9 times 1 is equals to 9. So x plus 9 is equals to 12. And then we bring 9 to the right side. So x equals to 12 minus 9. So the value will be x equals to 3. So now we're going to find the value of y here. So we're going to substitute equation 3 into equation 2. So y plus 19 over 2 times 1, which is value z, is equals to 27 over 2. So y plus 19 over 2 is equals to 27 over 2. We're going to bring the 19 over 2 to the right side. So y equals to 27 over 2 minus 19 over 2. And then the answer is y equals to 8 over 2. But we can simplify that. So it will be y equals to 4. Therefore, we already have the values of x, y, z, which is x equals to 3, y equals to 4, and then z equals to 1.